Hello friends, welcome back to Domain Analytics program by 360DigiTMG. So we are looking into education data analytics and we have started with application of education data analytics. So we have seen from where we are going to get this data. So we'll be getting this data from different, it could be a university data, be a data that we can get from different schools. We may be getting data from students. We may be getting data from different examinations. So all this data that we are looking into, okay, all this data that we are studying about students, professors, trainers, education institutions, all this data is coming from education sector. And the analysis of this particular data is called as education data analytics. So let's do a short recap of what we have seen earlier. So basically we have started looking into the applications. Then we have seen the CRISP MLQ methodology. So what do we have in CRISP MLQ methodology? So the project management methodology that we use in data science is MLQ methodology. So the abbreviation is gross industry standard process for machine learning with quality assurance. So there are six different phases that we have here: business understanding, data preparation, model building, evaluation, model deployment, monitoring, and maintenance. So these are the 6 different phases that we have in CRISP-ML. So first phase that we have is business understanding. So in business understanding, we have a problem statement and we are trying to solve that problem by using data science. So we are going to get some data. Okay, here we are looking into educational data. So we are going to get, we are going to solve. Okay, we are going to provide a solution for the analysis. So the second phase that we have is data understanding. So the 5 data mining processes, okay, that we have something looking into is, for example, like data mining. It for extraction of this information from the data, we requires data preparation, model building, model testing, and computing lift for a model applying, and we have something called as model deployment. So these are the 6 different phases that are important. So when it comes to business understanding, so we have to understand the project objectives. So when it comes to business understanding here, so let us first discuss about business understanding. So we have business understanding. Okay, so in business understanding, so it is to understand the project objectives. So we have to understand the project objectives and requirements for the project. So you have to understand the project objectives and requirements. And we have to get these objectives and requirements in business perspective. So here we are looking into education data. So if I have an education data, we will be looking into objectives and requirements in education data perspective. And then we have to convert this knowledge into data mining problem. So these knowledge that we are getting here, that will be converted into data mining prime. So when it comes to data understanding, okay, so the second phase that we have here is, so it's a combination of both the business understanding and data understanding that we have. So what is data understanding? So when we look into data understanding, we start by collecting data. So the process starts by collecting data. Okay, the process starts by collecting data. Then we get familiar with the data. So we try to understand the data. So we get familiar with the data here to identify data quality problems. So we will be understanding the data quality problems in, okay, and to discover first insights into the data. So what are the first insights that we have with the data that we'll be looking into? Along with that, we'll be looking into different subsets and all this. So the hidden information, if there is any hidden information, we try to get that information in data understanding phase. Then we have data preparation. So when it comes to data preparation, so what do we have here? So it includes all activities that are required to construct final data set. So data that will be fed into modeling tool. So that we are trying to prepare here. From the initial raw data that we are getting from the process, from the business stakeholder. Okay, so that data we are going to take, and we are going to construct the final changes that are required before feeding our model. So tasks include here are like table, case, and attribute selection, as well as the transformation, cleaning of data for modeling tools. All these are different things that we are going to do in data preparation. So what about model building? So when we look into model building part, select and apply a variety of modeling techniques and calibrate tool parameters to optimal values. So we'll be looking into different modeling techniques, and we are going to calibrate the tool parameters. So the hyperparameter tuning, called as hyperparameter tuning, that we are going to do. Some techniques have specific requirements on the form of data. So we have to, so the model that we are going to use, that should be, that should suit the data that we are going to have. And when it comes to evaluation phase, thoroughly we are going to evaluate the model and review the steps executed to construct the model to be certain it properly achieves the business objectives or not. So we determine if there is some important business issue that has not been sufficiently considered. So at the end of this phase, a decision on this use of the data mining results in it is reached. So we have the business understanding, data understanding, and data preparation phases. And here we are looking into modeling. Right? So modeling is one phase we have, and we have to evaluate this model. So model evaluation. And finally, we have the phase called as deployment. So we are going to organize and present the results of data mining, and deployment can be as simple as generating a report or as complex as implementing a repeatable data mining process again and again. So data mining is iterative. So a data mining process continues after a solution is deployed. So this is very important phase. So see, these are the different phases that we have here. In the same way, when we look into the data understanding phase, so data understanding plays an important role in machine learning phase. Okay. So the data understanding phase of the CRISP MLQ methodology, it involves taking a closer look at the data available for mining. So this step is critical in avoiding unexpected problems during the next phase, data preparation. So before data preparation, once we are going to give a close look into the data, what are the different data types we have, like, and from where we have got this data. So data collection and data types are two different steps that we are going to look into when it comes to data understanding. So when it comes to data understanding, we have two data types mainly. One is continuous data type and the other is discrete data type. So when it comes to continuous data type, we have interval, ratio, and the data which can be represented in decimal format, and it makes sense, it is called as continuous data type. So when we have ratio, okay, ratio data is objective and interval data is subjective. Okay, ratio data is objective and interval data is subjective. So, and when it comes to discrete data, so these are categorical, and again categorical data is divided into binary and multiple. So multiple is divided into nominal and ordinal. So these are the different types. And when it comes to qualitative versus quantitative, so again the data is divided into qualitative and quantitative. And we have structured versus semi-structured versus unstructured data. So what is structured data we have here? Structured data that we have is the structured data is that data which can be represented in tabular format. So what is structured data? So that is something we are going to look into. In the same way, we have unstructured data. Unstructured data, the examples are videos, images, audio or speech, or textual data. So these are certain examples of. So we have big data versus non-big data, which speaks about the volume of data. So the four V's that are important here are volume, huge volume of data we have, velocity, data generated at a speed, rapid speed, variety, video, images, audio, text, etc., veracity, uncertainty in the data. So these are four V's that we have here. Cross-sectional data. So cross-sectional data that we have here is date and time and the sequence in which you have data does not matter. So we have multiple variables here. So time series data, date and time and sequence in which we have data matters. So data should always be arranged in a sequence. We have single variable and one time variable for sorting in sequence. So longitudinal data or panel data, it's a combination of both cross-sectional data as well as time series data. So in balanced data, we have seen that there are different methods we have. So balanced data and imbalanced data. So these are different data types that we have. So already we have seen. So when it comes to data collection, we have primary data source and secondary. So then we have also looked into data preparation. Right, when it comes to data preparation, we have seen there are different techniques like typecasting, handling duplicates, outlines. So all these are different techniques. So when it comes to typecasting, converting one data type to Converting one data type to another data type is called as typecasting. So the examples that we have are integer to float, array to strings. These are the examples. And in Python, we are going to use as type is the function that we are going to use. And when it comes to handling duplicates, so getting single source of truth from various entries is one such example. So when we have duplicates, there is no other way. So we have to remove the duplicates. So data, okay, data is the data set that we have. Data set name that we have given dot the variable dot duplicated. So first we are going to identify if there are any duplicates in my data. So once I find the duplicates, okay, once I finalize the duplicates, I am going to work on drop underscore duplicates. So I'm going to remove these values by using these codes. So when we have outliers, so outliers are extreme values in the data. So the three are technique we are going to use. Okay, rectify, retain, and remove. So we have masking. Outliers exist, but you fail to detect outliers. So it is a false negative question. And we have swamping, detecting non-outliers as outliers. So it's a false positive. And vincerization. So this technique modifies the sample distribution of random variables by removing outliers. So 90% vincerization means all data below 5th percentile is set to 5th percentile and all data above 95th percentile is set to 95th percentile. So these are the different codes we have. From feature engine dot outliers, we import vincerizer, and in vincerizer we are going to have the capping method IQR, the tail we have O, fold 1.5, and these are the variables. So the column name, whatever we have there, that column we are going to use. So we have the next method that we have is if alpha is set as 5%, then lower and upper 5% values are trimmed. So we can set the percentage. So trimming is the method that we use to remove outliers. So we are going to specify the outliers like by using the upper limit and lower limit. We have seen the IQR method, the box plot. So we are going to find the Q3 value and Q1 value, Q3 minus Q1 value versus IQR. So using the IQR value, we are going to find the upper limit and lower limit values. And based on that, we are going to remove the outliers. So trimming is different than inspiration. So trimming is something related to, so here we are going to retain the value and here we are going to remove the value. So we have something called as zero and near zero variance. So usually we ignore the columns with the same entries throughout, or if majority of the entries are same. So all entries of column called country show the same name as USA. I am going to ignore that column and I am going to work. So we have missing values. So the process is called as imputation. So we have variance. So missing completely at random, MCAR. Okay, we call it as MCAR. So we have the data and maybe because of manual error. Okay, so we are not going to take certain values will be missing. And when it comes to missingness at random, so when we are doing a survey, maybe the person who is answering these questions are not comfortable with answering that particular question. So maybe they are not avoiding and they are avoiding and they are not providing. So that value will be blank. And also missingness not at random. Okay, when we have missingness at not at random, so we are going to specify that that particular value is not applicable. So these are different values we are going to have when it comes to missing. So discretization, so converting continuous data to display data. So we have three different methods here again. So when it comes to binarization, converting continuous data into two categories. And when we have rounding method, rounding to nearest value, 5.6 will become 6 and 5.4 will become 5. We have binning. So fixed width binning. So adaptive binning. We have two types, fixed width binning and adaptive binning. So we are going to create dummy variable creation. Okay, we will be using dummy variable creation. So one hot encoding, label encoding, dummy encoding scheme. We have effect encoding scheme, bin counting scheme, feature hashing scheme. These are the different methods that we have in case of dummy variable creation. So we have different transformation methods. So we check for normal distribution first. If the data is not normally distributed, we are going to apply different methods. So we have log transformation, we have exponential transformation, square root, reciprocal. So we have box method where we take the lambda value. Okay, so if the lambda value is equal to -3, that implies that y to the power of -3 is equal to 1 by y to the power of 3. If lambda is equal to -2, that implies that y to the power of -2 is equal to 1 by y to the power of -2. So lambda is equal to -1 implies y to the power of -1, that is equal to 1 by y to the power of -1. So in the same way we have when we have lambda is equal to -0.5, it implies y to the power of -0.5, that is equal to 1 by square root of 1. So how do you apply the log value? Okay, in the same way we are going to apply the lambda value. In the same way, when we are going to look into lambda is equal to 0 implies log transformation, lambda is equal to 0.5 implies square root transformation. Standardization or normalization, it will make the data scale free and limitless. So there are three different techniques we have. Standardized scaling we have, and in standardized scaling we have x minus mean divided by standard deviation is the formula. Mean value becomes 0 and standard deviation becomes 1. So the code that we have is we have something called as standard scalar. Okay, that is the function that we have to perform standardization, which comes from scalar. So in the same way, we have normalization method, which is also called as min-max scaling or range method. So the formula is x minus minimum divided by maximum minus minimum. So the code that we are going to get here is from scalar, pre-processing, import, min-max scale. The third method that we have is robust scaling. So x minus median divided by IQ. And when we have textual data, we have several methods like tokenization, stemming or limitization, stop code removal, document similarity function. We have topic models, word embedding. All these are different techniques we are going to use when it comes to data manipulation, and the data is a string manipulation. Then we have seen the exploratory data analysis. So which is a combination of descriptive analytics and descriptive statistics. So we have the first moment business decision, we have second moment business decision, we have third moment business decision, and fourth moment business decision. So apart from that, we have to look into the graphical representations. So the first moment business decision is also known as measures of central tendency. So where we have three different measures. One is the statistical measures, mean, median, and mode. When it comes to mean value, it is also called as average. Okay, it gets influenced by outliers. So middle most value of the data set does not get influenced by outliers. So value which repeats maximum times, single mode, unimodal, two modes, it is bimodal, greater than two modes, it is multimodal. So more modes implies presence of clusters. The second moment business decision is called as measures of dispersion. So we have variance, standard deviation, and range. So variance is something related. So variance, it gives the disadvantage is that units get squared. So square root of variance. Okay, the advantage is that we get back our original inputs from square. So range is maximum minus minimum. So we have a third moment business decision, that is skewness. So we are trying to find the asymmetry here. Okay, measure of asymmetry is also called as measure of asymmetry. So we have negative skewness or left skewed. We have positive skewness or right skewed. If skewness is equal to 0, then it is normal distributed. Then we have fourth moment business decision, that is kurtosis. So kurtosis is equal to, when the kurtosis is equal to 3, that means that it is mesokurtic distribution or normal distribution. So if we subtract 3 from kurtosis, then it is called as excess kurtosis. And we have wide peak and thin tails that we can see when we have negative kurtosis is, and it is called as platykurtic distribution. And when we have thin peak and thick tail, it is called as positive kurtosis and is called as leptokurtic distribution. So when it comes to graphical representation, we have univariate, bivariate, and multivariate. So in case of univariate, we have bar plot, index plot, which is also called as univariate scatter plot. We have dot plot, strip plot, violin plot, stem and leaf plot, candle plot, pie chart, time series plots. And when it comes to histogram, we have primary purpose. We understand shape of data distribution, and secondary purpose is to identify outliers. And density plot, also called as a kernel plot or smoothened histogram. Box plot, or it is called as box and whisker plot. So primary purpose is identify outliers. Secondary purpose is understand shape of the data distribution. So we have quartiles and 5-number summary here. So minimum, first quartile is called as Q1, median is called as Q2 or second quartile, third quartile is called as Q3, and maximum value, and we have interquartile range, that is IQR is equal to Q3 minus Q. So we have multivariate analysis where we look into pair plots. Okay, we have pair plots and interaction plot. We also have a heat map, that is also a multivariate analysis. So that is something related to exploratory data analysis. We have feature engineering, where we look into feature engineering on temporal data. So when we have feature engineering on temporal data, we have date-based features and time-based features we have. And when we look into feature engineering on numeric data, so we have raw measures, binarization, rounding, interactions, binning, all these comes under the feature engineering on numeric data. So when it comes to feature engineering on categorical data, so we have transforming nominal features, transforming ordinal features, and encoding categories. So when it comes to text data, so we have certain feature engineering methods like bag of words model we have, we have bag of n grams model, TF-IDF model, we have document similarity, topic models, we have word. So feature engineering on image data. So image metadata features from EXIF data. So which contains image create date date and time, image dimensions, image compression format. So device make and model, and image resolution and aspect ratio, image artist. We have flash, aperture, focal length, exposure. And we can take the raw images and channel pixels. We can take the grayscale image pixels that we can take, binning image intensity distribution that we can take, image aggregation statistic we can take, edge detection, objection detection, localized feature extraction, visual bag of words model. All this comes under feature engineering on image data. So we can do the feature engineering on image data also. So we have feature extraction methods, automatic extraction, manual extraction, and principal component analysis. When it comes to feature selection method, we have like filter methods, we have wrapper methods, we have embedded methods, we have threshold based methods, we have. When it comes to statistical methods, we have Pearson correlation and hypothesis testing. We have a recursive feature elimination, model boost selection, subset selection methods. Again, in best subset selection, we have exhaustive approach where all combinations of inputs are regressed upon output. So when we look into forward stepwise selection, at each stage, consider the model with highest adjusted R square value and one additional input variable to the model at a time. We have backward stepwise selection, add all variables and then remove one input variable at a time. So these are certain subset selection methods that we have, and these are feature selection methods. So these are all part of feature engineering methods, and these are part of data preparation. Okay. Along with that, we should be looking into certain statistical measures like probability. We have like number of interested. The formula for probability is number of interested events divided by total number of events. We have joint probability and we have conditional probability. So when it comes to conditional probability is defined as the likelihood of an event or outcome occurring based on the occurrence of a previous event or outcome. So conditional probability is calculated by multiplying the probability of the preceding event by the updated probability of the succeeding or conditional event. For example, if conditional probability will be taken as, can be taken as P A by B, we have is the probability of an event A occurring. Probability of an event A occurring given the event B. Okay, event A occurring from the event B. So for example, given that we drew a red card. Okay, we have certain cards and we draw a red card here. And what's the probability that it's a 4, okay, 4. So what's the probability that P of 4 by red is equal to 2 by 26. Okay, so that is equal to 1 by 30. So out of 26 red cards, given a red card, there are 2 4s. So we have the probabilities 1 by 30. So that is the conditional probability that we are looking. So in the same way, we have joint property. So in the same way, we have something called as joint probability. So what is joint probability? So given two random variables that are defined on the same probability space, if we take, if I have, so A and B. Okay, so this is the common conjunction that we have. So it is defined as AU intersection. So how we are going to explain this, right? So when we given two random variables that are defined on the same probability space, the joint probability distribution is the corresponding probability distribution on all possible pairs of objects. So the joint distribution can just as well be considered for any given number of random variables. So when it comes to probability distribution, so x-axis, I'm going to have the random variable, and x is when x is continuous, it is called as continuous probability distribution. And when I have the continuous probability distribution, we will be looking into different distribution factors here. Like we can take the normal distribution, standard normal distribution we have, where we look into Z distribution. We have chi-square distribution, Fisher's F distribution. We have students T distribution, T score we are going to get. It is also called as T distribution. So it is used when sigma is unknown. And calculating probability value from T value requires two parameters, confidence level and degrees of freedom. And apart from that, we have gamma distribution, the exponential distribution, we have beta distribution, the log normal distribution. All these are different distributions that we are going to look into when we have a continuous data. So when I have a discrete data, we'll be looking into Bernoulli distribution, binomial distribution, geometric. We have hypergeometric distribution, multinomial distribution, Poisson distribution. All these are part of discrete probability distribution. So when my x-axis is either it would be a continuous or discrete value. So when it comes to inferential statistics, work on sample but draw inferences about the population. So we have population data, we have sample frame. We'll be looking into simple random sampling or other sampling techniques we have, and we'll be getting a sample. And a form of inferential statistics. Okay, so that is hypothesis testing. So again, when we look into hypothesis testing, there are different methods we have here. So parametric versus non-parametric test we have, null hypothesis, alternate hypothesis we have. Okay, so we'll be looking into confidence level, type 1 error we have, type 2 error that we have. Okay, it is also called as alpha error. The significance level will be usually set as 0.05. And type 2 error we have, it is called as beta error we have. Okay, y is continuous and compare with external standard. So normality test we have. All these are different things that we are going to have in hypothesis testing. So when it comes to mathematical foundation, we will be looking into optimization, the rate of change. Okay, if we change x-axis value, then what is the amount of change in y-axis? So something that we are going to look into, and it is also called as derivative, gradient, or slope. So derivative of a single value is undefined. Okay, can be assumed 0, and these are the different rules that we are going to look into when it comes to mathematical foundation. So these are the base equation that we are going to look at is y is equal to f of x. Okay, so when we come to model building, so we have power rule, the sum rule, constant multiple rule, the difference rule, product rule, quotient rule. All these are different rules that we have to evaluate the derivative. So the procedure for optimizing a single argument function. Okay, steps to determine the minima and maxima values. So given y is equal to f of x, find the first derivative value, set the first derivative of f of x to 0 to identify the critical value, find the second derivative of f of x. So this is the process to find the minima and maxima. So now we have seen So we have seen the three different phases: data understanding, business understanding, data understanding, and data preparation. Now we are looking into model building. So as we have discussed earlier, for example, so let's take an initial data set here. Okay, if I have an initial data set, so this data set I have in a database. So from here, so this is the initial data set I have. From here, the next process that we are going to look into is EDA. So to this process, so we have exploratory data analysis. So we first start with exploratory data analysis. So this could also include the processes like PCA. Okay, so these are certain techniques we can use. Okay, next we are going to take this data to the next level. Okay, like we start with data cleansing, or we also have a process called as data curation. We remove the redundant features. So these are the different processes that we have. Okay. So from here, so this is the pre-processed data that we have. The next stage that we have is the pre-processed data. Pre-processed data set we are going to have. Now, when we look into the data practically, what are we going to have? So I am going to have the rows and columns here. Okay, this is the structured data we are dealing with. So here, for example, I have the input values x1, x2, x3, x4, x5, s6, right? And I have y column, right? So I may have a categorical data, or I may have a continuous data. So if I have the output variable, okay, so here we are looking into these are the input variables. And here we have the output. So this is the pre-processed data that we are looking into. So now what we are going to do, so this is something related to the supervised learning. Okay, now we are looking into supervised learning model. We are going to split the data. We are going to split the data into two different data sets. So one, we have 80% of data here, and the other we have 20% of data. So we are going to use this as the training set here, and we are going to use this as testing set. So from here, how we are going to evaluate this process here. So the next process is like we are going to use this for learning algorithms. Okay, so it could be any model. Okay, it could be any model like the SVM. We may have a KNN model. So these are the models that we are going to look at. So I may use any of these models here. So after once apply these models here, I am going to have the validation techniques, right? So here we have a classification data. So we are looking into cross validation techniques. We are having cross validation techniques we are going to look into, and then we have the trained model. Okay, finally we are going to get a trained model. So we are going to compare. So in between, we'll be looking into hyperparameter optimization. So we have also one step, that is hyperparameter optimization. We are going to optimize the whole process. So on the same model, in the same model, we are going to work on the optimization and classification. So we are looking into that. So there will be two different process. Like we have a classification when my output is discrete, and we have a regression when my output is continuous. So if I have a classification model, I'll be looking into accuracy. These are the evaluation metrics we are like, I am going to look into sensitivity, specificity, or in case of regression, I will be looking into R square factor, or the MSC, RMSC, MAPE. All these are different evaluation. So finally, we are going to get a predicted Y. Okay, Y hat. Okay, we are looking into predicted Y. So this is an overview of the process that we are going to see. So first, we are going to start. So when we look into this process here, so when it comes to model building, we start. So there are two different types of learning that we have. Okay, one is supervised learning we have, the other is unsupervised learning we have. And basically, the model building is data mining process or machine learning process. So we are going. So it's an extraction of information. We call it as extraction of information. So in case of first, we are going to start with unsupervised learning. So we are going to look into unsupervised learning here. In unsupervised learning, we have different techniques. So we have the clustering technique, we have dimension reduction, association rules, recommendation system, we have network analytics, text mining. All these are different models we have in unsupervised learning. And again, when we look deeper, okay, in clustering model itself, there are many different techniques. Okay, so basically, we start with hierarchical clustering, which contains agglomerative clustering and divisive clustering. And when again we look into agglomerative clustering, it is a bottom-up approach. We start with singleton clusters, continuously merge two clusters at a time to build a bottom-up hierarchy of clusters. So we can look into we visualize using dendrogram, which is generated after algorithm is run. Okay, so we decide the number of clusters by analyzing the dendrogram, and the distance is used to find the similarity between the items are distance between two records. Okay, I'm going to find the distance between two records. So for numerical data, we'll be looking into Euclidean distance. We have Minkowski distance, Manhattan distance, Mallow. In the same way, when we have for categorical data, we have binary Euclidean distance, simple matching distance, checkers. For categorical, we have if the two categories are same, then distance will be 0. And when we have mixed data, one method that we have is normalize the numeric data into the range of 0 to 1, perform one-hot encoding, then we can calculate the Euclidean distance. Or I can also use Gover's general dissimilarity. So these are the different functions that we have, okay, when we are trying to find the distance between two records. And distance between a cluster. Okay, when I am trying to find a distance between a record and a cluster, or between two clusters, I am going to. So we are going to perform. Okay, it is performed by using linkage functions and using distance measures like Euclidean, Manhattan, and Mahalanobis. So these are called as linkage functions. We have a single linkage method, also called as nearest neighbor. Okay, so also called as nearest neighbor, minimum distance between members of the two clusters we have here. And complete linkage, we have also called as farthest neighbor, greatest distance between members of the two clusters. Average linkage, average of all distances between members of two clusters. Centroid, we have distance between their centroids. And group average, okay, agglomerative clustering we have. And we have Watt's criterion. Okay, these are the different linkage functions that we have. So apart from this, we'll be looking into distance properties. So distance should be non-negative. Distance from one record, okay, distance from a record to itself will be always be zero. Distance from I to J will be equal to distance from J to I. These are the different properties of distances we have. And normalize or standardize the data before finding the distance. And cluster evaluation, we have four different techniques. Silhouette coefficient we have, inertia we have, so smaller the better, range from 0 and goes up. We have higher the better, we have range from 0 to 1, higher the better. So we have done index, ranges from 0 to infinity, higher the better. We have Davis Biden index, ranges from. So these are the different cluster evaluation techniques. So this is something related to agglomerative cluster. In the same way, we are going to look into the non-hierarchical clustering methods, that is k-means clustering. So in k-means again, so there are different methods we have. So we are going to start with k-means clustering on Monday. Okay, we'll be looking at our first machine learning model on Monday, where we are going to discuss the first model with a data set that comes from the education data. Thank you, friends. Have a great day.